topic, we will discuss more into vectors. So the intended learning outcomes of this video will be the following. So illustrate vectors and their properties, solve problems involving vectors, differentiate vector and scalar quantities, and that's it. Okay. Actually, the second intended learning outcome can be further expanded later on. So the outline, we will be discussing first the coordinate systems, vectors, illustrating vectors in general, and then the unit vectors and the dot product and the cross product of vectors. Okay, now so we begin with the coordinate system. So the coordinate system is a plane. Now we start with a two-dimensional the plane, in at which we could pinpoint any point in this plane using two values, which are the abscissa, the x, the abscissa, and the ordinate, the y. So given x and y, we can pinpoint any point in the plane. So this is not the only way to write a point in the plane. We can also utilize the polar coordinates, which are in terms of the r and the theta. So the r meaning that is just the radius, and theta as the angle. So we want to figure out here, how could we transform Cartesian coordinates into polar coordinates and vice versa, polar coordinates to Cartesian plane. So given this scenario, at which this point here is again this point xy, how do we transform this into its polar coordinates? So since, as you can see here, that this is just a right triangle, we can utilize the Pythagorean theorem, which is just r squared is equal to x squared plus y squared. Okay, to simplify this, r is just equal to the square root of x squared plus y squared. So that will be for the r. So Cartesian to polar, and then to find the angle, it actually depends. No? So since this is assuming that this is just in the first quadrant, the angle theta will be equal to arctangent, or sorry, let's create the identity first. No? So tangent theta is the opposite, no, over the adjacent. So we have tangent theta is equal to y over x. Therefore, we can simplify this theta into arctangent x over y. Okay? And then what if we have a given polar coordinate? How do we transform this polar coordinate into its Cartesian coordinate system? So given this one, or given the r and theta, we could determine a relationship between theta, x, and r using the cosine function, as you can see. So if you could remember in your trigonometry, cosine theta is equal to the adjacent over the hypotenuse. So the adjacent here, if this is the theta, the adjacent is x, and then the hypotenuse is y. So, sorry, not y, but r. Okay, so therefore, r cosine theta is equal to x. Or we can swap this position, the positions, we have x is equal to r cos theta. Then another one, we have sine theta. So we can relate this theta, y, and r respectively using the sine identity. So the sine identity is just opposite over the hypotenuse. So therefore, this is equal to y over r. Okay, manipulating this, we have r sine theta is equal to y. Therefore, y is equal to r sine theta. Okay, so again, this is when we have a Cartesian into polar, and if we have a polar to Cartesian. Okay, so let's move on to the next one. So the Cartesian coordinate of a point in the xy plane, or xy, is equal to negative 3.5 and negative 2.5, as shown in the figure. Find the polar coordinates of this point. Okay, so we have a given coordinate negative 3.5 and negative 2.5. We want to find the polar coordinate. So again, we could just find the r. That is just the square root of x squared and y squared. So we have a given coordinate system x and y. So this is equal to negative 3.5. And then outside, this is the square. And then we have negative 2.5. Outside is the square. So therefore, r is equal to, use your calculators. We have here the square root of 3.5 or negative 3.5, to be exact. You can actually omit the negative sign if you're going to square, since it will just cancel out. So the answer is 4.3. Okay, I will just write this down on 4 significant figures. So 4.301. So this is in meters, so we write this in meter. So now we want to find the theta. Okay, so we are utilizing here the positive angle, wherein the domain of the angle is from 0 degrees to 360. Okay, so this will be the domain for this force, at least at this point. So please remember that we will use this 0 to 360, wherein the positive angle is the counterclockwise direction. So meaning that this will be 90 degrees, this will be 180, and this will be 270, and so on. If you want to find this angle, this will be negative, also negative, right? If this will be clockwise. Okay, so let's find the theta. So theta is equal to what? So how do we visualize this? No? Actually, we should visualize this first. So actually, this r has a coordinate of, we have here negative 3.5. So this is the x. So meaning we have here negative 3. 1, 2, 3.5. This is the negative 3.5. So this should be negative 3.5. And then we have negative 2.5. So downwards, negative 2.5. Okay. So to find this theta, okay, at least we have this alpha first now. Let's solve for alpha first here. So to solve for alpha, we need to utilize the arctangent. So tangent here, we have arctangent negative 2.5 over negative 3.5. Okay, and that will be our angle. So this should be equal to what we have here. So shift arctangent and the negative 2.5 over negative 3.5. So we will assume here, or we will find the absolute value of this. This should be in degrees. So let's solve this in degrees. So we have here 35.54 degrees. Be mindful, guys, to take note here. Let's just find always the absolute value so that this will always be positive. So if we have a negative, the negative of this evaluation, let's make it positive for now. So we have here 35.54. Is that right? Is that final? So not yet. Since your angle, the angle that we solve here is this theta, and we want to find this theta, therefore it should be, so it should be 180 plus alpha. So this should be added with 180 degrees. So theta therefore is plus 180, we have 215.5. 215.5 degrees. Alright, so we don't have to worry about the significant figures for now, but actually to remember, if you have 3 significant figures and you perform an operation of multiplication and addition, you have to consider the rules of significant figures. But anyways, to make things simple, I'll just utilize 4 significant figures every time. Meaning you have 4 digits of significance. Okay. Let's move on to the next example. So 2 points in xy plane have Cartesian coordinates 2 and negative 4. and negative 3 and 3. Determine the distance between these points and their polar coordinates. Okay, so let's visualize this first. So we have, excuse me. So we have 2 and negative 4. So let's say this is 2. I will not scale this down, guys. So we have 1, 2, 1, 2, 3, and 4. So this is your first point. And then we have negative 3 and 3. We have negative, so negative going to the right, and then positive 3 going upwards. 1, 2, 3. So therefore, this will be your point. So we want to figure out what is the distance in between these 2 points. Okay. So how do we find the distance between these 2 points? So we can utilize here the Pythagorean theorem again. But just remember this one, guys. This is already discussed in your analytic geometry course or pre-calculus course, that the distance that is equal to the square root of x2 minus x1 squared plus we have y2 minus y1 squared. Okay. So we have already given here, this is x1, this is y1, this is x2, y2. The distance between these two can be solved. So we have x2, negative 3, and then minus 2 squared plus we have y2, 3 minus negative 4. So this will become plus, no? Minus negative 4, no? Or this will be 3 plus 4 squared. So the distance in between these two, we have the square root of, we have negative 5 squared plus 7 squared. So the answer should be square root of 74 or 8.602. So don't forget the unit. So this is in meters, so this should be in meters. Okay, so we want to find also the polar coordinates. So we have to find this first polar coordinate and this other polar coordinate. Also we want to find R, and then theta. So the theta here will be this, and the other theta will be all around. So to find for the first point, for 2 and negative 4, we have R is equal to the square root of 2 squared plus negative 4 squared. That is equal to, let's calculate. So I'll just submit the negative sign since this will just cancel out. So we have 2 square root of 5 or 4.472 in meters. Okay. And then for theta, so for the theta here, we have this theta. Since this is outside our quadrant, we should add here 90 degrees. If you visualize this first, we have here this theta. Actually, we should subtract 180 degrees, no? So this is the theta we're trying to look for, and we could actually solve here. Is this alpha. So we just have to solve this alpha first and then subtract 180. So 1/2 of the revolution is 180 degrees. So 180 degrees is equal to the sum of alpha plus theta. Okay, so to find for alpha, that will be just this angle. So for the first one, I'll just write this down here. We have this triangle. So this is negative 3, right? And then positive 3. So let's just not consider the signs here first. We will just assume that this will always be positive. So to compute for theta transposing this to the other side, we have 180 minus alpha, which is equal to, so alpha here is equal to arctangent. We have 3/3. So basically this is 45 degrees. Okay, so if you will notice here, I did not consider the negative now. So because I will assume that this is an absolute value. Okay, so theta here therefore will be equal to 180 degrees minus 45. That is 135 degrees. Okay, that is for the first point. For the second point, the R will be equal to, okay, the R will be equal to the square root of, I'm sorry, I swapped the thing. I swapped there, okay, I'm sorry. I swapped there, no. Okay, I should put here 3 and negative 3. I'm sorry, guys. It should be my first point. Gawin natin point 1 to. I am really sorry about this. So, this should be equal to, we have square root of 3 squared plus 3 squared. So, the R for the first one will be 4.24. Yeah. And then for the other one, we have negative 2, or sorry, positive 2 plus negative 4 squared. Okay, so therefore this will be, I forgot to answer this. So 2 squared plus, again, I will omit the negative sign since this will just cancel out. So 4.47 in meters. Don't forget the meters. And then what's the next one? The theta. So for the theta, we can visualize this. Again, we have this Cartesian coordinate system, and our point here is this one. So therefore, it should be, the theta should be like this. Always starting from the positive x-axis, counterclockwise. So we want to find for theta, but we could only solve for the alpha here. So this tiny gap here will be the alpha. So therefore, the theta plus alpha will be equal to 1 whole revolution, which is 360 degrees. So to solve for theta, that is just, let's write this down here, theta is equal to, we have 360 minus alpha. So if you transpose this alpha to the other side. So therefore, theta is equal to 360 minus alpha. So what is alpha here? So alpha, drawing this one, so drawing this triangle here, we have here this, based on the coordinate, we have 2 and negative 4. So this is our alpha. Therefore, this will be arctangent. We have negative 4 over 2. Although we could omit the negative 4, assuming that this is positive. Okay, so theta will be equal to, we have 360 minus arctangent 2. So the answer should be 296.6 degrees. Alright, so that's it. Okay, do we have another example? Okay, we have another example. So 2 points in a plane have polar coordinates 2.5 and 30 degrees and 3.8, 120 degrees. Determine the Cartesian coordinates of these points and the distance between them. So this is the contrary of what we did last example. Okay, let's visualize this anyways. I don't have a protractor. Let's just draw this to just visualize the problem. So we have 2.5 and 30 degrees. So this will be 30 degrees, approximately 30 degrees. And let's say you have 2.5. I'll make this shorter. So let's say this is 2.5. And then 3.8 and 120 degrees. So 120 degrees, guys, is somewhere here. Somewhere here. So this is your 120 degrees. And then the length of this will be 3.8. Alright. So we want to find the coordinates xy and their distance. So to find the distance, we want to first find the coordinate system, the Cartesian coordinate system xy. So let's solve for the first one. I think let's solve for this one first. So 2.5. So we have 2.5 and 30 degrees. Okay. So to solve for its xy, we have x equal to r cosine theta. Based on the last slides. So we have here 2.5 meters, or let's just omit this. Let's just put this later. And then cosine 30 degrees. So this will be equal to, this should be equal to, this cannot be calculated directly. So we have 2.165, I'm sorry for that. 2.165 meters. Yes, meters. So this is the x coordinate. And for the y coordinate, we have r sine theta. So we have 2.5 sine 30 degrees. Okay, so just remove this cosine, change it to sine. So we have 1.25. Okay, so this is our coordinates. Okay, so this is already our coordinates, but be mindful, we did not have to change the sign since this is in quadrant 1. So the x here is positive, the y here is positive. Ano? So remember this as well. And then conversely, the x should be negative here, and the y should be negative here. So if on quadrant 1, both of the x and y are positive. Okay, so let's put this as 2.165 and 1.25. Okay, for the second one, we have 3.80 and 120 degrees. Okay, so how do we solve for this problem? So there is a problem here. You shouldn't use this 120 degrees directly, guys. You want to solve for this alpha here. So you want to solve for the angle here first. No? So we have here given 120 degrees. Therefore, this alpha, that is equal to 180 minus 120. That is equal to 60 degrees. So the 60 degrees is what you will use for your computations. So x is equal to r cosine theta. Or actually alpha na to, no? It should be alpha. So x is equal to r, or sorry, r is 3.8. And then cosine alpha, that is 60 degrees. Okay? So x is equal to 3.8 cosine 60. So this should be 1.9. Now be wary, guys, be wary that when you solve for a coordinate outside of the quadrant 1, you have to take note of the sign. So since this is going to the left, your x axis is going to the left, it should be negative. Okay? And then for y, we have r sine alpha. So for r sine alpha, we have here 3.80 and then cosine 60. Sine 60. So y here, that is equal to you have to use your calculator. I'm thinking about a quick solution, but it could be hard. Okay, so 3.291. So utilize 4 significant figures. 3.291 meters. So therefore, your other coordinate is, that is equal to negative 1.9 and 3.291. So this should be in meters, guys. I forgot to write here meters. Okay, we want to also find the distance. So to find the distance, we have d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Therefore, the distance is, so we have here the square root of, so the difference of x, we have 2.165. Okay. You can, I mean, this is commutative, no? x2 here could be x1, x1 could be x2. It should arrive at the same answer, no? So 2.165 minus 1.9. So we have plus 1.9 since double negative. Plus we have 1.25 minus 3.291 squared. So the distance between these 2 points is 4.549. Okay, so that will be all for today. Thank you guys for listening.